So I'm here today to talk about MLCube, which is a collaboration between a lot of different people within MLCommons. And I'm speaking, I'm one member of a working group, so I'm here to share kind of work that's being done by a whole bunch of people. And what MLCube is it started with a problem that we've observed. And in MLCommons and MLPerf, the benchmark, we work with a lot of different AI models, and we have to share a lot of different AI models between a lot of different companies and a lot of different organizations. And a lot of this involves, send me your model so I can reproduce your results, send me your benchmark so I can see if it's working. And so out of this, we kind of made this observation that it's too hard to use someone else's model. And generally speaking, if you want to reproduce someone's results, if you want to run their model and get to the same accuracy or get similar performance, it takes a lot of work. And because of this, we feel like there's a lot of time being lost in packaging and then repackaging people's models. So this is, the standard example of this in my mind is you find some new research model that's published, you go to their GitHub page, you can check it out and you can probably get it running after you download their data set. And maybe if it's pretty easy to do, maybe in 20 minutes or half an hour, you can maybe be up and running their model. But then if you want to move that into your internal cluster, like if you use a Kubernetes cluster or you use a cloud like AWS, if you want to get this into your kind of benchmark infrastructure, your continuous integration system, this is where things got more difficult because now you generally have to repackage it. You have to rewrite the inputs so you can read from your file system instead of the local file system. You want the distributed one, or you need to change the way the metrics are output to conform to a different format. And this is what makes it tricky to actually share these models. And because of this, we feel like there's a lot of lost products and features that can't get off the ground. Like if you wanted to, for example, have some continuous integration testing of the most popular models on GitHub to track how they're changing over time and to see if they're even running. This would be really difficult to do because you'd have to basically implement special glue code or special repackaging for every model, and it just doesn't get off the ground. And this leaves models that are basically unused or undiscovered because we just, we only have so many hours in the day, and it takes a lot of effort to work with these models. And so this is where we came to this vision of having, plug and play models. Basically, the idea is that we can get going with someone else's model really quickly and get it running in our infrastructure and our clusters right away without significant manual work, without going through the readmes. And what this solution looks like, what it looks like when we actually conceptualize it, to me, is it looks like a shipping container, basically, where the shipping container is a great metaphor for this because, you can put anything you want in it, and it really revolutionized how we transport goods around the world because it has this standard shape, the standard size. It's really simple, but it allows uniformity across all of our shipping from train to semis to boats. We have this huge amount of uniformity. And this is kind of what I would keep in my mind when I think of MLCube. And the idea is that it's, this simple, thin interface. It's not this complicated thing. It's not this difficult thing. And we narrow it down as much as we can. And it allows for the most portability possible. And I think the key insight here is that it's not opinionated. It doesn't insist you use certain libraries in your models. It doesn't insist you use certain languages for your models. It doesn't insist your models take particular forms or conform to specific APIs. We have as fewer opinions as possible. And so in this, we're going to look at, what is this shipping container? How does it work? And if you're curious, how can you get involved or how can you try it out? And where this positions itself. And I'm hammering this, I'm revisiting the same idea in a few different ways because I think this is a real differentiating factor in how we think about MLCube and how we're approaching the problem space. Because currently there's a lot of verticals in the problem space, right? Like you can get an all-in-one solution from various providers that will track your experiment, manage your hardware, manage your parameters, graph your results. There's a lot of these kind of all-in-one solutions that exist. And this is what I think about as like a vertical. Basically, you can do all these things with one big system that will do everything for you. And this is different than what MLCube seeks to do. MLCube seeks to be that horizontal, a layer that kind of decouples and just slots in a very thin way. Because we're not in this vertical space where we want to kind of build this ecosystem where you get all these, where you get all these features for one entry fee. Because our core goal, as I said, is we want to be able to move between these freely, right? Like if I'm at my company or my organization or my university and we use, maybe Singularity on a particular, cluster, and I want to send you my model and you use a different technology on a different cluster, we don't want to have to be like, oh no, it's not going to work because I'm using this and you're using that. I guess we'll have to do a lot of manual work here, right? The idea is that it's a common horizontal thin layer that's not really owned by any one person or organization that everyone can give input into that helps decouple these two parts of the stack. And so what this looks like in practice, and we're still very much in the early stages of, we have some prototypes out there and things like that, which I'll be walking through. We're still in the very early stages of this. So the basic idea is that every cube is a Docker image. It's a pointer to a Docker. And when I say Docker, I don't just mean Docker as in the Docker brand, but really Docker is a proxy for any open container interface image, which covers a large suite of different images. And so we're this Docker plus this metadata that you need to run the image, plus an interface for the image, plus supporting files like parameters. And we package all this up in a directory. And what MLCube really is describing what this directory has to have in it and where the pieces have to go in the directory. This is the core and the heart of it. We'll walk through examples with different runners and different models and things like that. And that's kind of as we talked about in the hourglass, those are the layers above and below. And so at its core, just think directory with a pointer to an image and some metadata and a few small files is the mental model of what a cube is at its core. And then you can copy this directory, you can have it on your GitHub, you can email it to someone if you just zip it up. It's small and portable. So in this directory, in this directory, we have this image. And this image will do a basic task for us. And this is the core abstraction that we offer, which is essentially a single invocation of the image, a single task, and it takes in files and directories and produces files and directories. So everything that comes into an MLCube is a directory or a file, and everything that leaves the MLCube is a directory or a file. So when you invoke your MLCube, you just speak in terms of the task you want done, whether it's downloading data or training or inferring. And then you just make sure you get it the right files and directories, and then you tell it where to put the output files and directories. So in this case, for a train task, we would take in a data set and parameters, and we produce a trained model and logs. And this would all be going to and from the file system. And you can probably see how this already creates kind of this natural pipelining approach, which is workflows and things like that we view as being a layer on top. If you wanted to have a pre-processed data for your data set, this is more sophisticated use cases, but you can see the building blocks here. And if we look at what this looks like in practice, It's fairly simple. We're going to walk through an example here where we check out in a training SSD from MLPerf. This is the SSD benchmark used by MLPerf for training. And we're going to run it using the MLCube default runner. So this is going to be our reference implementation of how to work with an MLCube. And I'm going to show you what it looks like using this default runner that you can install from pip. And again, this is our reference. This is what we create to make things easy for people to learn and to get started. But our ultimate hope, as we'll touch on later, is that this is not the only way of doing it. It's easy, and other people can create runners, and there's many different ways to run an MLCube besides just using our library. But to get set up very easily, you just clone and install MLCube. And if you wanted to download the data for the models, because there's a COCO data set that goes with this benchmark, you have no inputs and you produce one output by calling the download task. So this will actually just materialize on your local disk a directory containing the data set and everything you need, and you have no inputs for it. You can then train the model by taking this data set you downloaded and by combining it with these parameters. And these parameters are going to be like a JSON file that comes prepackaged in the cube. When we talked about a cube being a pointer to a Docker metadata plus some files, these extra files include these parameters, which are your default hyperparameters for learning rates and batch sizes and different optimization parameters. You then point the train task at this dataset directory and this parameters file, and then you produce a model directory and a logs file. And this is kind of the very simple high-level flow. And if you want to dig into the details then, like changing a parameter, you would do so by actually editing the parameters file. And if you wanted to investigate the log, you could investigate the logs file to see, information about the training, how the training progressed, what learning rate was reached, things like that. Sorry, what accuracy or quality was reached. And then you can pipeline this by taking inference data set and the model you trained and running the inference task. And this will produce a set of predictions and a set of logs describing, what kind of accuracy you reached on these predictions. So this is kind of the core workflow, is that you can have a very simple way of pointing at the directory that contains the MLCube, giving it a task, and you can work with files and directories on your file system to do standard machine learning tasks. So far we've been talking about these files and directories, and by default, they will choose reasonable places to put files and directories for you. But you can, if you want, use new parameters. And the way you would simply do that is by providing on the command line a pointer to new parameters file. So if you wanted to retrain the model and you wanted to use a larger batch size or a smaller batch size to accommodate the GPU you're using, or if you wanted to experiment with a new learning rate, you could just copy the file, create a new copy, change the parameters to what you wanted, and then just say, this time when you train, use this parameter file. And in fact, use this data set that we created, or that is from our local repository of data, to see how the model behaves. And I'm going to walk you through now kind of what this looks like in execution. So we talked about kind of the philosophy, we talked about how to interact with it as an end user. And so now let's look at what actually happens behind the scenes. And basically, what we've already talked about in the last example is you're the user, you write some inputs like these new parameters to a file in your file system. And then when you evoke this runner, when you say run my task, you're really giving it three things. You're giving it the pointer to the MLCube directory. You're giving it the paths to the files that you want to operate on. So this would be your data set and your parameters file, in addition to the outputs, which are your model and your logs. So you're saying this is where you put the outputs, this is where you read your inputs, and you get the name of the task, like train or infer or download data. And this is all you need. And what the runner does is the runner will go to the internet and it'll go find the image, right? The MLCube is a directory. It has a pointer to the Docker image. It'll go find that image for you on the internet and it'll download it. And then what the runner will do is it'll set it up in your actual execution environment. And it'll set up the image on top of Docker, or if you're using Kubernetes, or if you're using Podman, it'll use Podman or Kubernetes or whatever your cluster manager is. And then inside the container is a main file, and the runner communicates with that main file. And it'll say, here are the input, here are the file paths, here is the dataset directory, here's the parameters file, here's where to write the logs to, here's where to write the model to. And it'll say, this is the task you run, and the main file will go do that execution. And then because we can mount files in the container and as a virtual file system, the container then can communicate with your local file system or your distributed file system. And it can read the inputs and write the outputs as appropriate. And then as the user, you can then read back the log file or go copy the model directory out somewhere else you want to go, or the model or the serialized model. And so this is the basic flow. You send in these, the user interacts very simply with the system. The user speaks files, and the user speaks, this is the task. And it's just dealing with files and knowing what task you want to do. And behind the scenes then, MLCube or the runner that supports MLCube will do all of the containerization, all of the setup for you, so the user has this very simple, clean experience. And the user hopefully would be you. So as I said, what I walked you through so far is our reference implementation. And we, as MLCube, hope that we're not the only people who are making and using MLCube, obviously. And like I said before, this is a collaboration. So our hope is that anyone who's making products or services in this space can leverage the work we're doing in MLCube and can build on top of it. So we don't really want to create some vertical like I described where, it's like, it has to be using our pip package and it has to be using our this and our that, right? We're not a vertical. We're not interested in, being opinionated about the rest of your stack. We're just really trying to minimize our footprint here. Also, we're not a product. We're not here to try and, gain, create a company or to gain any kind of user base for our libraries, right? Like ultimately, our libraries exist as a reference, as an example, as a starting point for other people to do their work, but not as the end product. And, we're not here to do money. As much as, people love making money, we're not here to be a business. We're really a bunch of people who are just kind of fed up with how difficult this problem space is and how much time we lose tackling these problems. So we're not here, we're just here to save our time and save our sanity. And insofar as we have an agenda, it fundamentally is letting models move freely as best they can, that anyone can run a model and that anyone can share a model, and really reducing the friction of sharing those models, because we think that that's where, one, innovation and growth in AI comes from, is sharing of models between different organizations. And also, just selfishly, we're a lot of people who have to actually work with models on a daily basis that are shared. So, selfishly, we get tired of having to rewrite for the 100th time a model or debug the same problem for the 100th time. So, really, we just want things to be easy and fast in the industry. As far as making an MLCube, it's pretty easy, especially if you already are familiar with Docker or any other container technology like Podman or Kubernetes. And we have some simple recipes and some guides. I'll walk you through the very basic idea right here, which is take your Docker image, create a new main file, and we actually have tools that can help automatically generate a main file for you. So this could be as easy as kind of just running one command to generate a new main file for you. And then you fill out a little bit of metadata to describe what your cube does, right? We talked about these tasks. You kind of list, these are the tasks my cube can perform. This image can download data for you. It can pre-process data for you. It can train a model, and it can infer using that trained model, right? So you'll fill out, saying what the tasks are. And these are kind of 3 core things you can do. And again, like we know a lot of people, there's 100 different ways to package a model. There's 100 different people who want you to do things 100 different ways. And we're really looking to build tools and utilities to help make onboarding to MLCube easy, because we think that one of the core problems to this is really making it easy for people. And my mental model is that like the core user should be someone who's about to publish a paper, and the deadline's the next day, and they decided, oh, I want to, before I publish, quickly share this as an MLCube, right? We're really targeting that use case where it's kind of last minute, just get it done really quickly and it works. That's our goal, is to make it super easy and super simple to get this going. And for overall, like I said before, simple, clean interface, file-based. It's based on, when I say Docker, I really mean OCI images, which is pretty much every image you'll commonly work with today. There's a special caveat for singularity that we're looking at, but pretty much any other container type system works with it, including Kubernetes, Podman. And fundamentally, this is collaborative. This exists as a group of people who feel this pain and believe in these problems, right? This comes from people who have had to deal with things like this before. And so if you're interested in this space, we'd love to have you contribute. We'd love to have you involved. We meet weekly on Friday, 9 to 10 Pacific time. We have a web presence where you can get links to our GitHub, or you can just Google MLCube or MLCommons MLCube, and it'll get you to our website and to our GitHub. Please do feel free to reach out to us. We have a mailing list of MLCube at mlcommons.org. Feel free to email me personally, and I'm happy to answer any and all questions you have on the topic. And that's all I have for you today. Thank you very much.